Hi, this is Javin Kharod, a chemical engineer by profession, going to continue our today's topic, multi-component distillation. Now, multi-component distillation is a chemical process in which a mixture of volatile compound separate based on their boiling point. The process occurs in a distillation column, a vertical stacking of tray or stages upon which component in their liquid and vapor phase coexist. As the mixture move up the column, high boiling compound concentrate on lower stages while lower boiling compound concentrate on higher stages. The distillation column use basic principle of vapor liquid equilibrium mixture. As heat is applied in a liquid, the liquid temperature rises until reaching a boiling point. At the boiling point, additional energy does not cause temperature increases, rather the molecule use it escape the liquid phase and become a gas. The energy absorbed by a new gas molecule is no longer available to heat the next liquid molecule. As the liquid boils, it is also cooling from the absence of the energy keeping the gas molecule in a gas phase. The cooling will cause the sum of the gas molecule condense into liquid, again releasing energy of vaporization. The energy release is able to reheat the liquid. The equilibrium condition, the rate of vaporization equal rate of condensation. In a multi-component distillation column, an equilibrium mixture is established on each stage. There are constant sources, new energy supplied to the bottom of the column. The heat causes some of the gas phase molecules of the most volatile compound. In each stage, the one with the lowest boiling point rise the next stage. At this higher stage, the mixture will attempt to come equilibrium again. The molecule coming from below may have too high a boiling point vaporize on this stage, so they accumulate in the liquid phase. Eventually, the liquid in each stage become concentrated in one or more of the component. Side stream may be taken off, and one or more stage, the liquid stream will be concentrated in one or more component. The additional distillation step may be necessary. Now, move further. The petroleum is the typical distilled into fraction via multi-component distillation. A fraction is a range of similar compound with close boiling point can be treated as the single compound. The gasoline is an example. The lower boiling point gas may be taken off the top of the column and not require further processing. The design of multi-component distillation requires complex calculation. The compound design parameter includes specifying number of stages, the feed stage of raw material, the stage at which product stream they are removed, and the heat needed to drive the column. Specialized multi-component distillation computer program perform this calculation, but engineer still learn graphical solution method to understand the process. The petroleum is typically distilled into fraction via multi-component distillation. A fraction is range of similar component and compound with close boiling point that can be treated as the single compound. Gasoline is an example. A low boiling point gas may be taken off the top of the column, not required for the processing. Now, short question according to multi-component distillation. What is the heavy key distillation? If you line up all components in order of their boiling point, to draw a line between two of them, the more volatile component is called light key and the less volatile component is called heavy key. What is light non-key? The light non-key is referred when non-key is more volatile than the light key, whereas heavy non-key is less volatile than the heavy key. Proper selection of the key component important multi-component separation adequately specified. What is Gilliland equations? An empirical equation used to estimate number of stages required in a distillation column. It used minimum number of stages as well, minimum and actual reflux ratio in the calculation. It is named after American chemical engineer Edwin Gilliland. What does Fenske equation determine? Yes, Fenske equation in continued fractional distillation is an equation used for calculating minimum number of theoretical stages required to separation of binary fission, the fractional column that is being operated at the total reflex. Now, what is assumption made in Fenske equation derivation? The derivation of the Fenske equation assumes that the relative volatility is a constant in the distillation column. Theoretical plates are often referred to as theoretical tray or equilibrium stages. What is Fenske Underwood Gilliland method? The mathematical model of the column obtained by performing total mass balance, the partial mass balance of component I. The Fenske Underwood Gilliland method is used to find the functional relationship between the composition of the bottom and the dome of the column. What is light key recovery? The component that have their distilled the bottom fractional recovery specified, they are called key element. The most volatile key, they are called light key, and less volatile is called heavy key. Now, what is light and heavy key in distillation column? The two streams coming out of distillation column separated by light key and heavy key. The light and heavy key are defined by their molecular weight and boiling point. The light key by definition has the lower boiling point than the heavy key. How do you determine light and heavy key? If you line up all components in order of their boiling point, draw a line between two of them, the more volatile component is called light key and the less volatile component is called the heavy key. What is light key in bottom? The light key, a lighter component, means component with a lower boiling point, defined lightest component in the bottom product, significant amount. And what is light key recovery? The component that have their distillation and bottom fractional recovery specified called key element. The most volatile of the key is called light key and the least volatile is called the heavy key. The two streams coming out of distillation column separated by the light and heavy key. The light and heavy key are defined by their molecular weight, boiling point. The light key definition has the lower boiling point than the heavy key. The distillation is the most common unit of resin for separating liquid mixture into valuable high purity product. The normal procedure for solving a typical multi-component distillation problem to solve material balance, equilibrium, summation and heat, short form MESH, balance equation stage by stage through computer program are normally available for religious solution. The MESH equations shortcut method, they are still useful preliminary design work and as aid in defining problems. The computer simulation, this article describes a widely used shortcut distillation method, commonly referred Fenske Underwood Gilliland method. Now, what is that? The component that have distillate and bottom fractional recovery specified called key element. The most volatile of the key is called the light key and the least volatile is called heavy key. The other components are called non-key. First step is choose light key and heavy key. Fix their distribution in top and bottom product. Next step, to estimate overall top and bottom flow rate composition, assuming only light non-key component, the top and heavy non-key component in bottom. The first step, the estimate dew point for top composition and bubble point for bottom composition. Estimate relative volatility with respect to high key and all components at the top and bottom. Now, important question. What is light key and heavy key in distillation process? The light key is most volatile, example ethanol, and heavy key is the less volatile, example water. Which equation used to calculate minimum number of stages in multi-component distillation column? If the number of stages is known, equation can be used to estimate the split of component between the top and bottom of the column, the total reflex bottom of the column at total reflex. Now, what is Underwood equation used for? The Fenske Underwood equation used for calculating minimum number of theoretical stages or plate. What is Fenske Underwood Gilliland method? The mathematical model, the column obtained by performing total mass balance partial mass balance. The component I, the Fenske Underwood Killian method, used to find fractional relationship between the composition, bottom and dome of the column. Now, estimate minimum reflux ratio using Underwood equation, where Underwood constant theta is calculated. The root of following equation 1 less than theta less than alpha ln key and q is the quantity of heat. The selection of operating reflux ratio R is the factor of minimum reflux ratio. Typically factor 1.2 is considered. Now, how do you calculate minimum reflux ratio? The reflux ratio is defined ratio of the liquid return to column, the divided liquid removed as product, also known as column as series of theoretical left. Mathematical R is equal to L upon T. How do you find minimum reflux ratio in Ponchon-Sauri method? In McCabe-Thiele method, total 8 number of stages are required for desired separation. By Ponchon-Sauri method, reflux ratio is 1.4. Minimum number of stages required estimated to be 7. Now, move further. What is minimum external reflux ratio? The cost of optimum reflux ratio typically in the 1.1 to 1.5 range depending on energy cost, condenser, coolant, material construction. The rule of thumb reported most often suggests the reflux ratio about 1.2 times the minimum is a good design value. Now, what is infinite reflux ratio? The infinite reflux ratio, minimum reflux ratio, optimum reflux ratio, effect of reflux ratio, the number of plate or tray in a distillation column. The reflux ratio is the ratio of the amount of the liquid feedback to column as reflux to amount of liquid withdrawn distilled. Now, what happens when reflux ratio too high? If the reflux rate is too high, too much liquid will flow down the column. Then the column top will be cooled too much. Over condensation may be occur. Too much vapor will condense inside the column before reaching the top, leading to flooding. Now, how do you find minimum reflux ratio? The minimum reflux ratio, draw a line from the xt, yd passing through x1, y1 with the intercept xt upon Rn plus 1 on y-axis. Reflux ratio calculated 1.5 times the minimum reflux ratio. Which is following true? The minimum reflux ratio. The explanation for minimum reflux ratio, all the condensed vapor become distilled, no reflux, so it requires infinite number of tray. Can minimum reflux ratio be less than 1? In the case where all reflux is collected as distilled, the reflux ratio would be 0.1. No distilled is collected, then the reflux ratio not assigned. Instead, we call total reflux or equilibration. The higher the reflux ratio, the more vapor oblique liquid contact that can occur distillation column. Okay guys, this is up to multi-component distillation. Next chapter, we have seen another topic of the chemical engineering. Still then, goodbye. Do take good care of yourself and enjoy your Sunday.